Hey guys, this is Professor Abood, and this week we are going to talk about liquid-liquid extraction. So liquid-liquid extraction is basically a way to separate a compound from one liquid into the other using the properties of each liquid, usually the polarity of liquids, to separate this compound. In this case, we are actually going to separate a mixture containing an acid and a neutral compound, using their solubilities in liquid-liquid systems at different pH values. So I would highly recommend reading these definitions like extraction, polar covalent bonds, polar molecules. I honestly don't have the time to go over each one of them in this video, and you guys would probably all get bored, so I'll let you do that on your own, but you should become familiar with what these terms are. So essentially, much like TLC, we need to know a few rules about liquid-liquid extraction. So like in TLC, you have like polarities are miscible. So for example, something that is a highly polar compound like water and another highly polar compound like ethyl alcohol will dissolve in each other, whereas compounds with dissimilar or unlike polarities are not miscible. So for example, you've got oil and water here. So oil is non-polar and water is very polar. So those two will not be miscible. It goes over about the higher average density. So all that means is that in a liquid-liquid system, what's going to come to the top is going to be the lighter layer, and what's going to be on the bottom is the heavier layer. And I don't mean literally heavier, it's just more dense. So if in 1 liter of water, if 1 liter of water weighs 1 kilogram, then 1 liter of oil must weigh less than 1 kilogram, I think it's about 0.7 kilograms per liter, in order for the oil to float on top. So it has to be lighter than water by volume or by density. So the lower average density will float to the top, and the upper layer will be the lower average density will be on the top, and the higher density one will be on the bottom. It also talks about some acids that can be made water soluble when reacted, and we're actually going to use one of those organic acids, and we're going to react it with and we'll go over that in a little bit. So what you're going to do is you're going to have a little vial with these two mixtures, and we don't know at what sort of compositions these are. So you might have 50-50, you might have 80-20%, you might have all benzoic acid, or you might have all triphenylmethane, but you don't know what you have. And so both of these compounds, this one is highly nonpolar. Benzoic acid is a little bit polar, but not very much. However, when reacted with a base, as we see right here, so we're removing this hydrogen right here, and that is going to create a negative right there, or a minus, and that is going to make this a very polar compound. So we're going to use this reaction, and we're going to use the fact that we can use oil and water, or oil and organic solvents and polar solvents in order to separate these two. So what are we going to do? We're going to place the contents. So we're going to take our little unknown vial, which will have 1 gram of benzoic acid and triphenylmethane, which we don't know at what compositions, and we're going to put it into a little beaker. In the meantime, we're going to add 50 milliliters of diethyl ether, and I'm sure you guys actually do know what diethyl ether is, because you've probably all seen it in the movies where someone puts it's basically the ether that people inhale to fall asleep. It used to be used, like a painkiller, and I think as an anesthetic as well. So don't breathe in the ether, or you might end up falling asleep in class or in lab. So once we have that mix, what we're going to do is we're going to put a stopcock on it, and essentially just try to mix the beaker up. And here we see that, well, so this isn't quite the, so this is just getting all of your solution. You just want to make sure that all the particles, because this is going to be this mix of benzoic acid and triphenylmethane is going to be a solid. So you just want to make sure that you get all of your solid into your funnel. And then we're going to mix it up and extract the benzoic acid, or we're going to convert the benzoic acid to sodium benzoate. And that, remember, that is right here, this reaction right here. So we're going to need to remove this hydrogen. So we're going to add some sodium hydroxide. And the sodium hydroxide also contains a ton of water. So if we go into here, and this is what a nice liquid-liquid extraction looks like. So you can see that there's a lot of organic solvents going up and a lot of water-like polar compounds going down. You also have a nice picture in here. This is when you just poured it in and it's starting to separate. You can see the oil, which weighs less, the oil, which is a non-polar compound, start to gather at the top, and the water, which is heavier, start gathering at the bottom. Same there. And so this is what your actual solution will look a lot like, because you'll have ether on the top, which is a nice clear substance, and you'll have water on the bottom, but you'll be able to see a nice separation between the two. And this is what your beaker, or not beaker, separatory funnel will look like. So I just wanted you guys to know what you were going to put it into. So you add essentially water and sodium hydroxide, and what that will do is that will change the benzoic acid into sodium benzoate. And then you'll mix it. And when you mix it, you have to be careful, because what's going to happen, see here it says immediately vent the system by opening the stopcock. The reason you want to do that is actually right here, is that the solution, after you mix it, it will become warmer and make the ether more volatile. So that just means that it's going to expand into a gas very quickly, and if you don't open the stopcock quickly, your glass will explode. And you'll get ether everywhere, and hopefully you won't get cut. So let's just keep that in mind and make sure that when you mix the ether, you're careful to vent that extra pressure. So you're essentially going to make those two layers, one of water, well, not water, but water and sodium hydroxide, and you'll have the other one of the ethyl ether, which will be your organic compound at as the top layer. And what you're going to do is you're going to drain off the bottom layer, and that will help you separate out the benzoic acid from it'll be in sodium benzoate form, because remember that we did this reaction, and your triphenylmethane, which is your polar compounds. So the polar compound will stay in the top layer, while the sodium benzoate, which is ionic and water soluble, will go into the bottom layer, which has a lot of water and has a lot of sodium hydroxide. Although a lot of that will react. So anyhow, you then are going to essentially just rinse the organic layer, and then you're going to purify what you have. So you're going to have these two layers that you now separate into two beakers, and now you need to recover each one. So here we're going to recover triphenylmethane, and a little below we're going to recover benzoic acid. And so those are just essentially ways to purify our substance once we have our nice layer, because remember, we only have 1 gram of the two of these together, so we're not going to have a lot of that. So we're going to want to go through a few steps. We're going to dry the ether by shaking it with brine. What that will do is that brine has a lot of salt, and as we know, salt absorbs a lot of water, so it'll absorb a lot of the water out into the bottom layer with the brine. And you'll discard that bottom layer, because remember, we're trying to keep the organic layer, which has all of our triphenylmethane. We'll do another dry, this time with granules of anhydrous sodium sulfate. So that's just, again, to remove any water that remains in the solution. We'll then drain the organic layer into a 100 milliliter beaker and let it just sit, and decant it. And what decanting means is you're just taking off the bottom layer. And then we're going to evaporate the solvent under a fume hood. And ethyl ether probably doesn't require too much heat, so I'm not sure if we will be heating these. It looks like a round bottom flask, so we probably will be heating them. And then essentially you're going to be able to get your recovered triphenylmethane, and you're going to try to weigh it out, and you're going to try to find the purity of it. And how do we find the purity of it? Well, if we remember from our very first lab, we can use TLC to find if there are more than one compounds in there, and we can use the melting point to find the purity of what we have. So in a similar fashion, we're going to do some similar steps for the recovery of benzoic acid from sodium benzoate. So remember, since we are in this form, we're going to have to add a lot of acid to move it back to this form. So it talks in there about adding the acid and about essentially just drying it further. And you're going to do the same thing when you get done with that. You're going to check the purity with TLC and with melting point. So, and of course, all this stuff is that you do have to dispose of properly. Just make sure you read that. And I think that's it for this week's lab. So hopefully that will prepare you, and come with any questions that you might have, and make sure to read through these definitions. And that should prepare us for lab this week. All right, see you then.